Hi everyone, and welcome to my channel. My name is Bidur, and I'm going to introduce you to machine learning and what do we mean by it, and its applications, and the motivation behind learning machine learning in 2022. Alright, so let me first start by giving you by introducing myself. I hold master's degree in computing science. I do research in machine learning, NLP, AI, and I also enjoy teaching a lot. I hope you benefit from today's class. And without further ado, let's get started. So, what do we mean by machine learning, and why it's so popular now, and why do you hear it everywhere, and wherever you go you would see machine learning and data science and so on. Let's just go back a bit and explain something. If you look around you, you would see a lot of data everywhere. You would see pictures everywhere on Instagram, Snapchat, and all of these apps. You would see videos everywhere. You would see spreadsheets. There is a lot of data in the world right now that it becomes super easy for us to make use out of it and to derive knowledge out of this data. Also, there's a huge improvement in computing power, meaning the systems that we have and the hardware that we have now can handle all this data and can make use of it. So the formal definition of machine learning is, as Tom Mitchell said it, the study of computer algorithms that can improve automatically through experience and by the use of data. To better understand it, let's take a look at the Venn diagram you see on the screen, which illustrates machine learning and where it lies with respect to data science. Simply, as you can see, machine learning is the area of data science that is the intersection between computer science and math and statistics. In other words, we train computer models and functions using mathematical and statistical methods in order to make use of this data and to make data observations, predictions, and further analysis. Let's take a look at the different applications of machine learning and what do we mean by it. I think most of you guys have used Amazon. You bought something from Amazon, a book or a toy or whatever, and you always found yourself surprised. Wow, how does he know that I like this thing? How does he know that I want to buy this thing? It was only in my mind. I didn't write it anywhere. I didn't type it in the search. Why it's popping up on my screen? What you are experiencing is something we call recommendation systems. So basically, we train models such that it will learn the different products and preferences for each user, and it will show you the stuff that you might be interested in. Another application is ranking. Most of us are on Netflix. We watch TV series, movies, and so on, and we always find ourselves with you might like this. You might like this video, this new series. You might like this movie. This is based on your previous data it's predicting for you the future movies or TV shows that you might like. Another application of machine learning, which is different than the ranking and the recommendation system, is classification tasks. What do I mean by classification tasks? It means that I want to know what type of class something is. Let's say I have like a set of data describing patients' results like MRI, blood work, and all these images, like medical images, and I want to know whether this patient has a benign or malignant cancer cells. We can train machine learning systems that would predict that for us. Another application is called regression. Regression is to predict a continuous value. So in classification, we're predicting 0 or 1. We're predicting yes or no, exists or doesn't exist, black or white, or let's say black, white, red. Like we have certain classes. With regression, we're predicting continuous value. So we're predicting, let's say, house price. How would we predict the house price? Let's say 500K or 1 million or whatsoever. We would have a set of values describing this house. We call them features. Let's say the house size, the location, the neighborhood, the school rating, and so on. Another application of machine learning is clustering. What do we mean by clustering? This is very commonly used in social media. We would find groups for similar stuff, similar people, similar items, similar things. Let's say sleep training group. All the people that are interested in sleep training, they are clustered, like group, put in a group together. And this helps us transform unstructured data into structured data. Another application is anomaly detection. Let's say I want to detect if someone is using my credit card without me knowing that. I want to detect if there's any fraud on my credit card. We can train machine learning models that would predict that based on your previous use of your credit card and how what is the normal of your usage. So I can go on and give you 10 more examples of machine learning, but let's just you might think now in your head, why now we are moving into machine learning? What happened to the previous ways of doing stuff? We had technology before, we had computers before. Why we didn't use machine learning? The answer to this question is that before we mostly used something called rule-based approaches, which if else. So if the car is of model 2019 and up, its price is like this. If the model is the car model is 2019 and before, its price is this. So we had to hard code everything in order to make computers do what we wanted to do. And we didn't have the huge utility and the huge computing tools that we have nowadays. So nowadays we have hardware, actually hardware that can handle processing all this data. So we have data, it's free and it's everywhere, and we have computers that can accommodate this data and can utilize it for us. So we combine these two, and we train models, and we build algorithms that would provide us with the answers in a quicker way and in a more meaningful way. All right. Now, if I want to move now into the abstract, the last thing that I want to cover today is the general abstract machine learning process. So we first, usually we have a business problem, let's say, regardless of the domain, and we take this business problem, we format it in an ML problem. So we transform it from business problem into machine learning problem. Then we start the hustle of collecting the data and bringing all data that is relevant to my problem. So we start with the business problem, we rewrite it as the machine learning problem, we gather the data that is relevant to my business domain, we pre-process, we visualize, and we label this data such that we have now pre-processed and ready to use for training the data. After we have gathered all this data and we prepared it, we write it in numerical format such that it is usable to train the machine learning model in it. Okay, then after we have the data ready to be used, pre-processed and in numerical format, we pick the algorithm, the machine learning algorithm that fits our problem the most. So we choose whether it is a supervised problem or unsupervised problem, and knowing what to choose, supervised or unsupervised algorithm, is a whole big topic into machine learning that I would explain in a separate video. But for now, I just want you to know that there are mainly two types. There is three types, but there are two types of machine learning algorithms: supervised learning and unsupervised. And we mostly pick based on our data, whether it is labeled data or unlabeled data. Just for now, know that there is two types machine learning algorithms, one supervised and one unsupervised. Now, using the data and the algorithm, we begin training our machine learning model. You might ask yourself now, what do we mean by machine learning model? Which, in very simple words, a machine learning model is a block of code. Yeah, a block of code which you define its parameters, its features, and eventually you make it useful and you train the data using it. All right. I want to mention something. The quality of the data that you use into training your model determine how good your model is going to be. So you can't feed very bad data and trash data into a model and expect anything but trash. You can't expect good models from bad data. Okay, so you wanna collect high quality data to get high quality models and eventually train something and make something with high accuracy. Okay, after training, we fine-tune and evaluate our model to improve its performance in generating answers such that it meets our business problem goals, and we can eventually move it into production and deployment. Take a look at the illustration that I have on the screen by Adrasha. So we first start with the data collection. We do data preparation. The collection and the preparation, they come under the data management and data pre-processing umbrella. We move into model development. We feed it to train the model, and then we evaluate our model accuracy, and we can go back and forth to improve our model. After we reach an accuracy that we are happy with, we do we move it into the production and deployment. All right. This is it for today. In the next lecture, I'm going to dive more into each area I came on today. I'm going to explain supervised and unsupervised learning, the difference between them, and where do we use each one of them. And in the one after, the class after it, I'm going to show you how to write your first machine learning program and how you can design your own machine learning model. To see the coming videos, please make sure that you subscribe to my channel and leave a thumbs up, and see you in the next class. Thank you.